Here we will learn about transition matrix. We have a vector space V of dimension n. We have two bases. The first basis is S, the second basis is T. And we want to find the transition matrix that change from basis T to basis S. And that transition matrix is a matrix with n columns. The first column is the coordinate of vector T1 with respect to S. So this is the coordinate of T1 with respect to S. And the second column until the last column, the coordinate of the vector Tn in with respect to the basis S. So we want to go from T to S. And what we do is we write the coordinate of T1 with respect to S, coordinate of T2, coordinate of Tn with respect to S. And here's one way I can think about it. Why we have this? Does this make sense to write the matrix, the transition matrix from T to S like this? So we have a vector, say any vector x in the vector space V, and we know that we now are in the basis T, right? So okay, now we know the coordinate of x in term or with respect to the basic T, say x1t, x2t to xnt. I write x1t because this is the basis with respect to t, xnt. Okay, and this means that x is written as linear combinations x1t t1, right? X and T, Tn. Yeah, so they are all the coordinates. They are the coordinate of vector x with respect to the basic T. And now here's the coordinate of x with respect to T. What is the coordinate of x with respect to S? Okay, and the question is, what is the coordinate of x with respect to S? So we know that this vectors of T1 to Tn, they are all vectors, so I should write on the vector S1, Sn, T1, Tn. T1 to Tn. So T1 to Tn are vectors in V. And S is a basis of V. So we can write T1 to Tn in terms of linear combination of vector in S. T1 can be written as, say, a linear combination. So here, that's why we have the coordinate of T1 in terms of S is here. So T1 and Tn. Vectors in vector space V, S is a basis of V. So we write Tn as linear combination of vectors in S. Okay, so this step we find the coordinates of T1 in terms of S to coordinates of Tn in terms of S. Where this up here. Okay, so T1, say C1 or S1 plus Cn Sn. Okay, let's say C11 S1n Tn Cn1 S1 Cnn Sn. Okay, or in terms of coordinates of T1, the coordinate of T1 in S is this vector C11 to C1n, and so on. Tn with respect to S, the coordinates is Cn1 to Cnn. Okay. And now we have X is its combination, right? X is its combination. So X equal to x1t t1 plus until xnt tn is now we group them together with respect to S1 to Sn. So we have S1 with coefficient x1 t c1 1 plus xnt cn1. Now we group for Sn. Sn x1t c1n xnt cnn. Okay, so now what is this exactly? This is the coordinate of x, or x now is written as linear combination of vector in the basis S, right? So all of these is a coordinate of x in term or with respect to this basis S. So the coordinates of vector x with respect to S is this vector and what is this one exactly? This you can write as C11 Cn1 so C11 Cn1 is here. I want to have this column matrix on the coordinate of T1 in term or with respect to S, coordinate of T1 with respect to S, which is C11 to C1n, right? Which is this column vector C11 to C1n. Similar, we have the second column with respect correspond to the coordinate of the second vector, so T2 with respect to the basis S until the last column Cn1 Cnn. The coordinate of vector Tn with respect to the basis S, this term x1 t until xnt. So this one, this vector is a coordinate of x in term or with respect to the base t, is this? So this is coordinates, or you can write coordinates of x with respect to the basic S, basic T, I'm sorry. And this E will be the transition matrix from T to S. We go from T to S. This matrix, which is a matrix on the coordinate of T with respect to S. Right. That's why it makes sense to write like this. Coordinate of T1 with respect to S. Coordinate of T1 with respect to S. Coordinates of Tn with respect to S. Put in the column. Yes. Therefore, we have the transition matrix here. That's why it makes sense to define the transition matrix. Go from T to S at this matrix. So what does that mean? Suppose now we don't know the coordinates of X in terms of S, but we know a transition matrix, for example, and we know the coordinate of X in terms of with respect to T. We know how to go from T to S by this transition matrix, and we take this matrix, multiply this coordinate, which is a column vector. We will have the coordinate of X in terms of the new basis. Go from this basis, we know the coordinate of X in terms of this one, T. We know how to go from T to S. We take the multiplication, we get the coordinate of X in terms of this vector is basis S.